Yes, this is going to be good. I summon forth a model for science. You beckoned? Bull, what are you doing here? Why are you always naked? Red needs a model. Not that kind of model. I need to talk about hormones. I've got hormones. I need to show the inside. Oh, we can show his insides. Be afraid, fools, for darkness shall reign with a furious smiting. We're really reaching into the bin for all of our worn-out material, huh? You gotta give the people what they want, not like they've seen this material. Please, can we try not to fail? I make no promises. Promises are a coward's game. I'm out for blood. Ugh. Here goes nothing. All right, Red, show 'em what we're working with. Okay, so the endocrine system. It's responsible for homeostasis. Are we allowed to say that word? He's talking about maintaining the body's stable internal conditions. Read a book once in a while, you oaf. The endocrine system uses chemical messengers called hormones secreted from glands to affect target cells throughout the body. I tried summoning a model to show the various glands, but I guess you'll have to do, Bull. I think I have some paint or markers lying around here somewhere. I hope it won't be permanent. My body is a specimen. This is no time for arts and crafts. Nay, step into the shadowy labyrinth of mine darkest thoughts. See for yourself the many dark passages of the endocrine system. Did he pronounce it endocrine? Sounds made up to me. Forsooth, my limitless power abounds. Behold my mastery of the dark arts. This is just a black sheet. How did you even put this up? Silence, fool! Professor Spark is speaking. Up in your silly monkey brain are 3 glands, the pineal, hypothalamus, and pituitary. The pineal ticks away the hands of your internal clock, tapping the beat of circadian rhythms. But that is nothing compared to what comes next. Quiver in fear as the latter two take hold of nearly every hormonal function. The hypothalamus is the bridge between the lightning and the river, for it connects the nervous system to the power of the endocrine. Endocrine! Beneath this powerful behemoth is the true master of the domain, the pituitary gland. Between these two beasts, over a dozen hormones are unleashed to dominate your every move. No, incorrect. Yes, they influence a lot of functions, but movement is not one of them. Whose show is this, Red? Mine! This is my show. Now please let me talk. I have notes. I'm not finished. Next, the parathyroid regulates calcium and phosphorus. The thyroid controls your metabolism. The thymus is also there. The pancreas battles to control your blood sugar with its antagonizing horsemen, insulin and glucagon. The twin adrenal glands sit astride your kidneys, driving catecholamines, androgens, and glucocorticoids into the fray. Finally, the gonads, ovaries or testes, sometimes both, firing off an onslaught of androgens and powering reproductive functions. Fear me, all ye fools, and heed mine warning. The very balance of your precious physiology is at stake, for you tangle with the most influential of bodily systems, the endocrine. Bravo, do it again. It is pronounced endocrine. There are also some non-gland organs you left out, like the kidneys, intestines, and liver. These also secrete chemical messengers. And what about the axes? Ooh, axes? No, axes. Regulatory axes that connect the glands in the brain to the rest of the endocrine system. Specifically, these pathways, the HPA, HPG, and HPT axes, connect the hypothalamus and pituitary to the adrenals, gonads, and thyroid, respectively. All right, nerd, but how about a little more on hormones? Certainly, there are 2 general types, steroids and non-steroids. I'm listening. Slow down, Flex. Steroid hormones are those derived from cholesterol. They're fat-soluble and can cross the cell membrane. This allows them to go straight into the cytoplasm to deliver their message. Ooh, like possession. Creepy. Yeah, kind of. The other type, non-steroid hormones, are derived from amino acids. These are water-soluble and cannot cross the cell membrane. They instead bind to receptors on the cell surface that, in turn, activate second messengers to deliver their effect. Among the non-steroid hormones, you have classes such as amino acid derivatives and peptides, including polypeptides comprising chains of 50 or more amino acids. Not to mention paracrine and autocrine messengers, such as eicosanoids, that are lipid-soluble like steroids and can cross the cell membrane. These guys are short-lived, however. What now? Well done, Mastermind. You broke him. Endocrine specifically refers to long-distance chemical messaging from one gland to another gland, organ, or otherwise distant cell in the body. But there are two other signaling mechanisms. Autocrine signaling is when the secreting cell targets itself. You see this in tumors and immune cells. And paracrine refers to short-distance communication between the neighboring cells. This can be within the same gland or organ like the intestinal wall. And what about those telephone hormones, the ones that need second messengers? They bind to one of three kinds of membrane-bound receptors on the surface of the target cell. G-protein-coupled receptors, ion channel receptors, or enzyme-linked receptors. And the second messengers can be calcium ions, IP3, CAMP, DAG, or even reactive oxygen species. So, what exactly do hormones do? Am I talking to myself? Didn't we already go over this? No, Spark. You said they control your every move. I pointed out that you were wrong, and then you went back into your weird rant. Back to the void! No, come on! Releasing into the bloodstream, hormones act as chemical messengers, defying the odds to inflict their will on their target cell. Ugh. Just answer his question. Some hormones act to stimulate or inhibit the release of hormones from other glands. For example, hormones from the hypothalamus impose their agenda on the pituitary gland. Some hormones, such as growth hormone from the anterior pituitary or androgens from the gonads, stimulate growth of the body. Other hormones, such as vasopressin and aldosterone, help regulate water and electrolyte levels, while hormones from the thyroid, parathyroid, and pancreas directly regulate metabolic processes. And just as I sweep across the wreckage of a world that was ill-equipped to resist my disastrous onslaught, so too will your body bend in submission to the infinite dauntless power of the system endocrine. Endocrine! It's endocrine! You self-serving child! I just wanted to do a simple presentation on the endocrine system, but instead I get naked bull. Hey, I put my armor back on. And it's itchy. And Spark, the dark wizard, storming in to ruin my day with his nonsensical ramblings about the darkness and chaos and mispronounced words. I had a whole thing about the endocrine hierarchy planned. I was going to talk about how the hypothalamus and pituitary gland work in conjunction to influence other glands down the chain, but also how those glands can function independently of regulatory axes, but now it's ruined. You came in like a wrecking ball and everything is over. Sorcerer. What? Sorcerer. You called me a wizard, but I'm actually a sorcerer. You see, wizards read from spell books. It's all math and science with them, real nerd stuff, like you, actually. But my power is innate to my very being. I literally draw on dark forces from an altered dimension of existence and channel the suffering wrought by billions of eons of sadness and despair there into a finely tuned acute vector of destruction here in the mortal realm. Sparky, didn't you lose your magic when you got kicked out of the Dark Arts grotto for accidentally destroying a temple full of their most precious and ancient artifacts? Bull, you promised we would never discuss our backstories in public. I've got nothing. I was going to talk about the pineal and adrenal glands in a bit more detail, but you made me so angry that I stomped the crap out of my book. Well, why didn't you say something in the first place? Ooh, I think he's going to do it again, Red. No, please don't. Hit it. The pineal gland, sometimes referred to as the third eye. Ooh, kind of spooky. It certainly is, my muscle-bound friend. Oh, great. Now I'm here, too. The pineal gland is actually a component of the photoneuroendocrine system, placed at the tip of a spear formed by the retina and central nervous system. Just as your favorite master of the dark arts draws his power from shadow, the pineal gland secretes sleep-regulating melatonin, a hormone regulated by the circadian rhythm and suppressed by light. Like a vampire. Right again, big guy. Now how about you, Red? Know any cool facts about the pineal gland? Well, melatonin is an amino acid-derived hormone converted from tryptophan, so it cannot cross the cell membrane, to deliver its message, to enact its will and force its victim into slumber. Yeah, that. To, induce sleep, it first has to bind to a G protein-coupled receptor in the brain, and the second messenger, phospholipase C, delivers the message. It's not just melatonin either. The pineal gland also produces serotonin and the hallucinogenic compound DMT, and evidence illustrates a cyclical relationship between these chemicals. What about the signaling pathways? What an oddly specific question. You can still read the assignment a little bit. Circadian variations throughout the day play a role in not only influencing melatonin levels, which are highest in the morning, but also other hormones. For example, cortisol is twice as high in the morning as it is at night, whereas adrenal-corticotropic hormone, ACTH, in the hypothalamus is at its highest during sleep. The HPA axis is a major player in regulating the body's internal clock, and is impacted directly by the light-darkness cycle and influenced by melatonin levels, effectively making the pineal gland an influential component that precedes the HPA axis. How about the adrenal gland? Well, you've got two of them, one atop each kidney, and each is made up of two parts, the cortex and the medulla. The adrenal cortex is responsible for the steroids aldosterone and cortisol, and a small amount of sex hormones, although the volume pales in comparison to that which is produced by the gonads. The adrenal medulla produces the catecholamines epinephrine and norepinephrine. What do the hormones do? Aldosterone is the primary mineralocorticoid in humans, and it is involved in the regulation of water and electrolyte balance. The main function of aldosterone is to conserve sodium and remove potassium. These mechanisms increase blood volume. The HPA axis drives the release of the primary glucocorticoid cortisol. This hormone helps control metabolism by promoting gluconeogenesis, proteolysis, and lipolysis. Cortisol also protects you against the negative effects of stressors such as trauma, surgery, infections, and emotional stress. Tell the people at home about the signaling pathways. Can we do a game show for the next video? Cortisol is the precursor to steroids, so it is essential to their synthesis. The hypothalamic pituitary adrenal axis, HPA, is fully involved in the secretion of steroids and catecholamines from the adrenal glands. High-intensity or long-duration exercise will activate this axis, demonstrating that even so-called good stress can spike cortisol levels. Maybe you should stop reading before it affects you. Following secretion of the polypeptide hormone ACTH, pregnenolone is synthesized from cholesterol. This kicks off the production of glucocorticoids. Of the glucocorticoids secreted by the adrenal glands, aldosterone acts directly on cells of the kidney. What about the what's-its? Good, he's back. I never doubted. Bull, what are your options when you get attacked by monsters? Stab or punch? I was thinking more fight or flight, but gold star to you. The sympathetic nervous system is responsible for the fight or flight response, and that's where catecholamines from the adrenal medulla come in. Epinephrine and norepinephrine are amines that require second messengers to induce effects on their target cells. These receptors are called alpha and beta adrenergic receptors, and they trigger different effects. The effects are too many to dive into now, but they pretty much come down to inotropic effects that alter the force of heart contractions and chronotropic effects that alter heart rate.